Hi, this is Mr. Eaton with a Year 9 lesson on rational numbers. As always, remember to record some important information in the study notes section of your exercise books and to stop the video when you need to make these notes and also to answer some of the questions. Alright, so numbers that cannot be expressed as a fraction are called irrational numbers. So these are the numbers that when written with a decimal continue forever and ever and don't show any pattern of recurring decimals. So to write these numbers we need a special mathematical symbol such as the square root sign or pi. So for example, the square root of 2 is 1.41421356237. So you can see that there's no pattern there whatsoever. And also pi is written as 314.159.26536, and it just carries on with no specific pattern. So therefore we use special symbols to represent these numbers. If however there is a pattern or the decimal actually finishes, then the number can be expressed as a fraction. So these numbers are called rational numbers. So for example, the square root of 4 is equal to 2.00, or if we round it to no decimal places, is 2. Now when we do have numbers that show a repetitive pattern, we can actually write those as this, for example, 0.5 with a dot above it, 5 with a dot above it, 5 with a dot above it, or more correctly 0.5 with one dot, and we don't put the other 5 fives in. We just leave it as 0.5 with that little dot above the 5 saying that the 5 carries on and on and on and on. With this number down here we can see that there's a pattern with the 345, 345. So to denote that we go 2.345, and we could put little dots above them, but instead what we're going to do is put a line above it. That line means that these numbers underneath it continue over there, and they carry on there, and they'll carry on there. So that line denotes that this is a pattern that continues on forever. Right, let's look at equivalent fractions. So what you do to the denominator, you need to do to the numerator. That's one of the little rules to remember. So if I want to find an equivalent fraction for this, what I do to the numerator, I do to the denominator. Okay, or what I do to the denominator, I do to the numerator. So I want to multiply it by 2, and I'll do the denominator by 2. So 2 times 2 gives me 4, and 3 times 2 gives me 6. Therefore, an equivalent fraction for 2/3 is the same as 4/6. And so we can go on. And if I wanted a equivalent fraction for that one, I would simply just multiply it by 2 over 2, and that would give me 4 2s are 8 and 6 2s are 12. So 8 over 12, and we can keep going. So that is an equivalent fraction to that, is an equivalent fraction to that, and we can keep going on. Improper fractions occur when the numerator is bigger than the denominator. So this is an example of an improper fraction. Your numerator is 10 and your denominator is 3. Therefore your numerator is bigger than your denominator. Simplification of fractions means that we need to divide the numerator by the denominator. So in the previous slide we had 10 over 3. So what we need to do is we need to see how many times can 3 go into 10. Well, we know our times tables, and we know that 3 goes into 10 3 times, and what is left over? 1, because 3 times 3 is 9. So 9, subtract it from 10, gives me 1. 1 left over, 3, because that is our denominator. So what is a proper fraction? Well, a proper fraction is when the denominator is now bigger than the numerator. So for example, 2/7 shows us that the denominator is bigger than the numerator, and it can't be simplified any further, so that is now called a proper fraction. A mixed number is a whole number and a fraction. So this is an example of a mixed number, 2 and 3/5. Alright, our whole number, and we have a proper fraction because our denominator is bigger than our numerator. So 2 and 3/5 is a mixed number. While on the topic of mixed numbers, remember how to turn a mixed number into an improper fraction. Put the video on pause and give it a go, and come back when you're ready. Alright, how did we go? Well, the first thing we've got to do is we've got to multiply 2 by 5. So 2 times 5 is 10, good. And then we've got to add our 3. So that would give us 13 over 5. So 2 and 3/5 as a improper fraction is 13 over 5. Alright, let's see if you remember how to do this. Write this fraction as a decimal. It is 3 and 3/8. Put the video on pause and give it a go. Alright, well, the first thing I would have done is I would have left my 3 where it was, because I need to have a look at the 3/8. I need to sort that out to give me my decimal places. So I would say that I would do this, okay, where we have 3 being divided by 8. And remembering our short division, we say 8 goes into 3, well it can't, so we put a 0, and we put our decimal places down, and then we put a 0 over here. We now say, how many times does 8 go into 30? Well, 8 goes into 30 3 times, because 3/8 are 24. Well done. What is left over from 24? We have 6 left over to get to 30. So we now say, how many times does 8 go into 60? Put another 0 down. 8 goes into 60 7 times. 7/8 are 56. What's left over? We've got 4 left over. Put our 4 over there. How many times does 8 go into 40? Well, 8 goes into 40 exactly 5 times. And I'll just extend that over there. So our answer for 3 being divided by 8 is 0.375, and therefore this answer up here is decimal place 375. Alright, have a go at this one. Write this decimal as a fraction. What are you going to do to turn this decimal into a fraction? Put the video on pause and come back when you're ready. Right, well I hope you recognize that you can write the decimal 0.24 as 24 over, now how many decimal places have we got? That is tenths and that is 100, so therefore we've got it over 100. Alright, and we can simplify that by seeing how many times can 2 go into 24. It can go in 12 times, and 2 goes into 150 times. And those are still even numbers, so I can simplify it even further. How many times does 2 go into 12? Well, it goes in 6 times. How many times does 2 go into 50? It goes in 25 times. And that is pretty much as far as I can simplify it. So that can be simplified down to 6 over 25. Alright, so try and identify which fraction is largest. Is it 7/12 or is it 8/15? Have a quick go, see if you can work out which one is largest. Alright, well the first thing I'd have to do is I'd have to find out what my lowest common multiple of 12 and 15 were. Alright, so these are the multiples of 12, 12, 24, 36, 48 and 60, and multiples of 15. So what is my lowest common multiple? Well, I've got 60 there. Alright, so next thing I need to do is I need to multiply 7 by 1, 2, 3, 4, 5. Okay, and I need to multiply 12 by 5 to get the common multiple of 60. So I take 7 over 12 multiplied by 5 over 5. Where do I get that 5 over 5? Well, if I count my multiples of 12, that's my first, second, third, fourth and fifth. 60 is my fifth. Okay, with 15, my 60 is actually my fourth, so I've got to multiply 8/15 by 4/4. Alright, so I've multiplied 8/15 by 4/4, so 8 times 4 is 32, and 15 times 4 is 60. So I've now got a common denominator. I've got 60 over there, and I've got 60 over there. And now I can compare my numerators, 32 and 35 over there. So which fraction is the largest? Well, to answer that question, I've had a look at my numerator over there, and I can see that this is the larger numerator. Therefore, this fraction, and in this case 7/12, is actually larger. So therefore, 7/12 is larger than 8/15. And that's my answer.